Welcome to Emmelac online tutorial, and today before us is a problem in linear motion and physics. Alright, let's look at this. Now, a car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? Alright, let's begin. Now, first of all, you need to recognize all the parameters in this question. Now, first of all, the initial velocity of 25, which is u equals 25, and it reaches a velocity which is the final velocity v, which is 45 in 10 seconds. Now our t is 10 seconds. So we are asked now to find the acceleration, which is a equals to, we don't know. All right, so with these parameters here, we get to look for the equation that will help in solving these equations. Now, the right equation for this will be v equals to u plus at, and here's the reason. Here we have the final velocity, here we have the initial velocity, here we have the acceleration, and here we have the t. Now, implementing this, we can now replace all these parameters with their various values. Now, here we have 45 equals 25 plus a, which is unknown, then times 10, which is our time. Okay, so moving forward here, we say 45 equals 25 plus 10a. Now we can now collect like terms, so transposing this over to this side, this one becomes negative. So here we have 45 minus 25 equals to 10a. Alright, 25 minus 25 will give us 20 equals to 10a. Now divide both sides by divide both sides by 10. So here we have divided by 10, here divided by 10. This cancel this. Then our a here, 0 cancel 0, equals to 2 meters per second. Alright, this is the answer to this question. Let's move on to the next example. Here's another example. A car starts from rest and moves with a uniform acceleration of 30 meters per second for 20 seconds. Calculate the distance covered at the end of the motion. Alright, to start with solution. Now, first of all, you write out every parameters given in the equation. First of all, we were told that the car starts from rest, and when a car starts from rest or an object starts from rest, it means that the initial velocity equals 0 and moves with a uniform acceleration, that is a equals 30 meters per second square. Sorry, this should be second square. Now for the time, t equals 20 seconds. Now calculate the distance covered at the end of the motion. Now looking at this now, from the equation of motion, we have about two equations that has distance in it. Now we have that of s equals to ut plus at squared over. Alright, in this case here, this equation will then hence give us we are looking for the value of the distance. So here our u is 0, so here we can say that 0 times time, which is 20, then plus our a, which is 30, times our t, 20 squared. Now the whole of this particular one over 2. So as such here we can say s equals, now 0 times 20 will give us 0, now plus 30 times 20 raised to power 2 will give us 400 over 2. Now which will also give us now 2 here, 1, 2 in 400 will give us 200. So here we have 30 times 200, which will give us this times this. There will be 6. That many zeros here? 1, 2, 3. Now the unit here is in meter. 6,000 meter, and can also be said to be 6 kilometer. All right, move on to